Hey everyone, and welcome to the first video in a new series that I like to call Tech Tuesdays. We will dive into different tech industry related articles, functioning as a great listening and reading activity focused around an exciting topic, technology. And depending on if you leave a comment in the comment section, it can be a great writing exercise as well. Now, that being said, if this is something that you think is worthwhile, and possibly good exposure to some industry-based English, please go ahead and give a like, and don't forget to subscribe and click the notifications bell to be alerted to whenever a new one of these videos is dropped. Now, let's get started at the topic at hand, AI. I know it seems like an oversaturated topic at this point, and that everyone either has been singing its praises or complaining that it's somehow going to ruin the world. But I found an interesting article on Wired.com that I feel takes this topic in a unique direction. How to ensure progress when the programming is evolving faster than the current hardware. So again, this is an interesting article that I found on Wired.com about ChatGPT's hunger for energy that is possibly triggering this GPU revolution. So the actual hardware itself that is processing all of these AI programs that we're currently getting used to and welcoming into our everyday lives, people have been noticing that it's kind of really putting a strain on the hardware itself. Before we get into that, I'd like to kind of jump into some of the key vocabulary that we'll need to make sure we understand before we can really break down these articles. So first, we have a GPU. Now, what's a GPU for those of you who are uninitiated, who aren't tech geeks, who don't know the ins and outs of hardware? A GPU, or a graphics processing unit, is a special electronic unit originally made to make computer graphics and images look better. So you can think of this as like the graphics card, something that usually in the past, it was all the PC gamers who wanted these things to make their game look really well, or look really cool. It was first used in things like video cards for computers, and later it put in various devices like phones and game consoles. People discovered that GPUs could also be good at solving certain math problems quickly, especially those that can be solved at the same time, which we call parallel problems. Now GPUs are used for things like teaching computers to think, neural networks like ChatGPT, and for getting cryptocurrency like Bitcoin. Okay, then we have this thing called the excuse my pronunciation, this is a new term for me as well, stochastic processing unit, what they call an SPU. So this is a newer type of processor that processes information in a random way versus the older binary zeros and ones way that current processors use. So if you're familiar at all with programming languages, everything that a computer interprets all comes down to two binary signals, zeros and ones. And of those zeros and ones, hundreds and thousands of different arrangements are assembled together by the machine to read something, to understand something. So these, they use, they're essentially a stochastic or random process that they use. It's like it uses a group of random things. So it's a very random thing. It's not just on, off, one or zero. Each is connected to a specific part of a list, and this list is called an index set, and it helps them organize these random things. And as we'll discover a little bit later, it kind of uses the already randomness of electricity inside of a circuit board anyways, to kind of help process these calculations. Then we have something called thermodynamic computing, big word. So thermodynamics is a physics field studying heat, work, and temperature, while computing involves using computers for tasks. So then what is thermodynamic computing? That's where it uses the laws of thermodynamics for effective resource use. It's different from conventional and something called quantum computing. It focuses on maximizing software efficiency to limit hardware use. This creates a system that adapts to its environment, similar to nature, using self-organization and thermodynamics. So one thing you'll notice that people complain about with computers that run a long time or run really hard is that they get hot. They use up a lot of energy, they generate a lot of heat. That's generally why server rooms in businesses are constantly air conditioned. They're put in colder places because of these laws of thermodynamics. And this type of computing takes that into consideration and helps tweak the process to be more effective. Then we have something called reversible computing. Reversible computing is a system where each computational state has a unique previous state, allowing backwards computation. It's a paradigm that's deterministic in both forward and backward directions, complementing traditional computing without replacing it. And from what I've understood in this, now mind you, I know IT, I do not really understand all the concepts of computer engineering, electronics engineering, but I do know that when you write data to a data source, it's a permanent thing. You're constantly writing on something. You can't just you can't really erase it and write over. This is a way of somehow using logic that allows it to jump back and forth between two existing states. It's pretty cool stuff, which we'll talk about again. Then there's this thing called Moore's Law. Now, Moore's Law is the pattern observation that says that tiny parts in a computer, called computer chips specifically, called transistors, double every 2 years. It's a way of understanding how technology has been growing. So this guy Moore basically said, he predicted that in every 2 years, the amount of these little transistors inside a data chip will double. So everything's getting smaller, but they're getting more condensed with more and more and more transistors, which we'll come to realize here shortly. Eventually, space is going to run out, and then what are we going to do? So this is the main topic of this article, is basically AI platforms and energy consumption. Now, on one hand, things like ChatGPT, or as I had talked about in one of my classes, which is a great thing to check out if you have a chance. I talk about Grammarly. All these kind of generative AI programs are basically staples now in people's workloads. So these are things that are just commonplace in many different industries. Even in the job that I work during the day, we have Grammarly integrated into our email system. So I can write out a full email, but then if Grammarly notices some issue with my grammar or spelling or something, I'm automatically alerted and prompted to go ahead and change that. And this is all through AI. So whether you like it or not, AI is here. However, it's using a lot of energy. And as we'll talk about in the article, all that energy consumption is costing a lot of money as well. So not only is it running a potential risk of environmental impact with all the fossil fuels required to burn to produce the energy, but then the cost of all this stuff, it's just burning up more and more resources, and eventually we're going to get to a point where something's got to give, something's got to change. So let's jump into the article. We'll talk about different sections of the article here, break it down piece by piece, and then at the end, hopefully in the comment section, you can kind of give your feedback as well. What do you think about this topic? So the first section really talks about AI development challenges. There's the soaring cost of energy consumption and large-scale AI training, and the demand for GPUs, particularly from NVIDIA, who are the kingpins of this industry, is leading to increased expenses. So they kind of hold the monopoly right now on GPUs for the most part, of the faster ones anyways, and it's really starting to affect the industry. So one thing I wanted to point out here was that OpenAI had said that the training algorithm that now powers ChatGPT cost the firm over $100 million to operate. So this is just the training algorithm. They've created this algorithm just to train this thing how to think, and just to do that, it's cost $100,000 in trying to maintain and upgrade and keep track of all these chips, of all these GPUs that they have to just keep constantly throwing at this ever-evolving problem. So I don't know about you, but I've heard stories as well about Bitcoin mining and using up all this processing power and how it's basically almost melting the polar ice caps. I don't know about to that extent, but yeah, the argument is that if we continue down this path, if we continue using processors the way that we have been using, it's really going to kind of affect global climate change as well as all of the fossil fuels that we're burning for automobiles and personal uses as well. So something to keep in mind. Now, what do we do about this? So the next part of the article talks about these different startup companies and some of the ideas that they have. Startups challenging NVIDIA's dominance, proposing a radical rethink of computer chip design. So Normal Computing, it's a different company. They have an innovative stochastic, there's that word again, stochastic processing unit for statistical calculations. So according to the article, a conventional silicon chip runs computations by handling binary bits, that's the zeros and ones we talked about, representing information. Normal Computing's stochastics processing unit, or SPU, exploits the thermodynamic properties of electric oscillators to perform calculations using those random fluctuations that occur inside the circuits. And they also mention that well suited to handling these calculations, these chips, this could someday make it useful for building AI algorithms that can handle uncertainty, perhaps addressing the tendency of large language models to hallucinate outputs when unsure. So this is something that I'd heard about before as well with things like ChatGPT, where if you ask it to write a research paper on the theory of quantum mechanics and something else really complex, and it just doesn't know everything, it starts to just make up things. And instead of pulling from things that it knows or making clear connections, it just starts to hallucinate, as they call it, these random things, and just starts spewing information. And that's because it's limited by those zeros and ones. So they're thinking that by having this processor that allows just random paths to be created, processing paths, that this is something that may be able to accommodate these larger language models when partaking in the elaboration of more complex tasks. So if you can kind of think of it as the binary O's and ones, you've got this path or you've got this path, where the stochastic processing units are more like this rail yard here. You could just have all kinds of different branching pathways for the processing unit to take. And it doesn't take as long, doesn't use as much resources, so that's a good thing. Now there's another company here called Extropic, and they're exploring thermodynamic computing for AI, aiming for a paradigm shift in hardware design. So in the article, they mention a lack of progress harnessing quantum computers for machine learning spurred them to think about other ways of exploring physics to power the computations required for AI. So I know we didn't talk about this in the vocabulary, but there is this method of computing called quantum computing that works in quantum mechanics and physics, really, really small stuff. And they've been trying for years to have a breakthrough, trying to create even smaller nanoparticle processors to be able to process things a lot faster and a lot more efficiently than we currently have now, but they haven't had much success. So this company is basically trying something different, and they're saying we're trying to do all of neural computing tightly integrated in analog thermodynamic chips. So what is that? That is something that I had to look up even further, and I found this another awesome article, which, by the way, these articles I will link in the description of the video below. Feel free to check them out, do your own reading through it, come back, leave that comment, tell me your thoughts, what you think about it. But this article on New Scientist is really kind of describing more about what these analog chips are and what they can do. And in there, they mention that a current problem that our AI hardware has is that it must shuttle data back and forth from its memory to the processors in operations that cause significant bottlenecks, meaning that the time it takes for them to take something, pull it from memory, and then process it, and then put other new, things back into memory and pull new things, It's just taking too long for it to work in real time like the human brain does. So they've created a chip that performs calculations directly within its own memory. So these chips kind of function as both things in one. It's a twofer. It's two things for the price of one. You got storing the memory and then the processing ability in one chip itself. So this models the way that links between neurons and human brains, they vary in strength when learning new information or skills, something that is traditionally stored as a digital value in computer memory. This allows the new chip to store and process these weights without making millions of operations to recall or store data in distant memory chips. I just want to point out here the last part that I found was just incredible when you're thinking about these things. 12.4 trillion operations per second per watt is what these things can perform. It's up to 14 times more efficient than conventional processors. So these things are hugely fast because they cut out this middleman process. They don't have to constantly go and search, pull something from memory, and then process that information. It's all in one place. So I think that's really something really cool and really exciting that they're working on right now as well. However, that's not the only thing. Jumping back into the Wired.com article, we talk about things like Vieira computing here, exploring reversible computing as an alternative. So because of this challenge to Moore's Law, as we talk about here, even if Moore's Law wasn't slowing down, so even if every 2 years we kept adding more and more transistors, doubling the number in these tinier and tinier microchips, you still have a massive problem because the model sizes that OpenAI and others have been releasing are growing way faster than chip capacity. So we just do not currently have the ability to meet the demand that these AI programs need to process these bigger tasks. So Vieira Computing, a startup based in the UK, is developing silicon chips that work in a fundamentally different way to conventional ones, performing calculations without destroying information in the process. This approach is known as reversible computing. We could make components smaller, but the number one enemy is removing heat from the system fast enough. So we're coming back to thermodynamics, but I want to stop and talk about this interesting concept here of reversible computing and not destroying information in the process. So instead of having to constantly write over things, erase, write over, erase, write over, erase, write over, you've got these things that are written in place, and they give you an either or option that you don't have to erase one thing to replace it. You can just constantly switch back and forth between it. And this is supposed to kind of like the other chip where it kind of cuts out that process of having to reach for memory to process the thing. This is allowing you to have, instead of having to constantly write, erase, just writing things that you can come back to and take a different pathway. So again, really cool stuff. Then there are some other ideas, such as computing with light or harnessing sound waves, which are gaining traction. Every so often, something comes along which will be transformative for the whole of humanity, like jet engines, transistor microchips, or quantum computers. So one of the reasons that really made me choose this article to kind of talk about is I'm a huge sci-fi nerd. I love the idea of being able to travel to outer space, for example. And as you see in television shows like Star Trek or movies like Star Wars, there's this concept of being able to just fly off and go to a distant galaxy faster than the speed of light. Well, the problem with that is in reality, we are nowhere near that, and people still argue to this day that it's not really possible because we have matter, and matter can't travel faster than the speed of light. However, we can't even remotely reach the speed of light right now due to our current limitations. We have these dreams, we have this desire to go and reach the cosmos, to go to Mars, to go beyond, to go to the nearest star. But with our current limitations, with the engines, the propulsion systems that we have, we burn too much fuel and we just can't do it. So We have this need, we have this desire, we just don't have the ability to get there. And I feel like that's the same thing with computing. We've reached this point now of AI reaching a certain point where we have this desire, this need for it to go a specific way. Hopefully not the way of the Terminator, of Skynet, but in a way that it kind of has this more self-awareness to be able to really help humanity. And we're realizing that we're limited right now by the current chips that we have, the current GPUs that we're using. So it feels like we're on the precipice, on the cusp here. We're at the beginning of this new revolution of something that's coming, and we're just witnessing now all these awesome ideas to get us past this barrier. And let's talk about some of these more cool things. So there's even more exotic ideas, like moving away from using electricity inside of computer hardware are also gaining traction. So how to compute information using light to save energy. So think about that. Right now in the computer or the electronic device you're using to watch this video, everything is through electricity triggering these ones and zeros. This is using lasers, using light to transform things into data, which is, wow, how do you do that? That's awesome. And another cool thing, they showed that a group of researchers from Holland showed off an idea for a mechanical cochlear implant, those things that are surgically implanted in deaf people to help them hear sounds, that harnesses sound waves to power its computations. So this thing isn't charged by a battery, it's not using normal electricity to help the person hear. It's using those sound waves, that energy that's coming at it regardless anyways, to help it do its computing, which is crazy as well. Just a really, really awesome thing. So that was the article in a nutshell. Let me know in the comments what your opinion is on all of this. Which of these things do you think will be the new path forward? Most importantly, how do we make sure that this technology is accessible and affordable so that we don't have the same issues that these tech companies are running into again? I want to say thank you so much for watching. And again, please leave a like and subscribe to the channel if you like this content and you want to see more stuff like this in the future. And also make sure to follow Skyrocket on any of the social media channels as well. Thanks, and have a good one.